Something just stirred behind the sun, an ancient pilgrim from the stars. Silent, brilliant, uninvited. In July 2025, NASA's Sky Survey telescopes caught sight of a faint speck gliding through the outer dark. At first, it looked like an ordinary comet, until its speed broke the rules of our solar system. It wasn't bound by the sun's gravity. It wasn't born here. They named it 3I Atlas, only the third interstellar object ever discovered, after Oumuamua and Borisov. I for interstellar, Atlas for the telescope that found it. But what that simple name hides is a story spanning 10 billion years. Chati Tenaidefi is a wanderer older than our sun. Its composition and orbital modeling suggest it may have formed in the thick disk population of the Milky Way, stars forged in the early universe, long before our own star ignited. It was likely ejected by the gravitational chaos of a newborn planetary system billions of years ago, set adrift in interstellar night. Now, after eons of isolation, it is passing through the light of our star, and humanity has one brief chance to watch it. On October 29, 2025, 3I Atlas will reach perihelion, its closest approach to the Sun, about 203 million kilometers away. For weeks before and after, it will remain hidden behind the solar glare, invisible to ground telescopes. Only space probes like NASA's Punch and ESA's Solar Orbiter can trace its path during that fiery intersection. And yet, even before its full arrival, the data began to whisper anomalies, one after another. Defying every rule of cometary physics we know, anomaly. Iwan, using the James Webb Space Telescope, scientists detected that the coma, the cloud surrounding the nucleus, is overwhelmingly rich in carbon dioxide, with a CO2 H2O ratio of nearly 8:1. That is unheard of. No solar system comet displays such imbalance. Suggests this object was born in an environment colder and more radiation-scarred than anything near our sun, possibly in the outer shell of another stellar nursery. Anomaly: 2 spectrographs show 3I Atlas ejecting water vapor at staggering rates. One astronomer described it as a fire hose running at full blast. The pressure and thermal emission can't be explained by sunlight alone. The sublimation model breaks. Something beneath its crust is feeding the jets with unnatural persistence. Anomaly 3, according to astrophysicist Avi Loeb of Harvard. The brightness gradient in Hubble imagery doesn't match normal sunlight reflection. It behaves as if the object were emitting light itself. If that's true, then our understanding of its energy source, and possibly even its nature, must be rewritten. Anomaly 4A's, it moves sunward. The comet glows in hues of emerald. Most green comets owe that color to diatomic carbon breaking apart near the sun. But here, the emission starts far earlier than expected, suggesting exotic chemistry or molecules forged under alien stellar radiation. Anomaly. Instead of a classic tail streaming away from the sun, early images show a narrow jet thrusting toward it. Solar wind and pressure should make that impossible. Is it geometry, or something about internal magnetic alignment? Scientists don't yet know. Each discovery deepens the mystery. One anomaly can be dismissed as noise. 6 form a pattern. Statistically, the odds of an object this rare, this active, and this well-timed appearing in our system are about 1 in 10 quadrillion. It feels as though something wanted to be seen. And that is where our story turns, from data to destiny. Because if these numbers hold, then behind the veil of physics might lie something deeper, a signal, a mirror, or perhaps simply the universe reminding us how little we truly know. Behind the sun, in the furnace of its light, Atlas continues to move, and the instruments of Earth wait for its return. When 3I Atlas vanished behind the sun, the universe itself seemed to hold its breath. For 72 hours, no telescope could see it. The data streams from NASA's Punch and ESA's Solar Orbiter fell silent, as if something or someone had turned off the lights. Then, in late October 2025, a violent burst of radiation flared from the solar limb. A coronal wave rippled outward, blinding instruments for nearly 8 minutes. When the sensors cleared, 3I Atlas had reappeared, but it was no longer the same. The object's coma, once thin and translucent, had expanded into a vast emerald halo. Brighter than before, its spectrum split by new ultraviolet emission lines that had never been seen in any comet. Astronomers compared pre- and post-perihelion data and found a shift in the chemical ratio. The abundance of carbon dioxide had fallen sharply, replaced by strange ionized carbon chains. Long molecular fragments rarely formed outside of nebular shocks. It was as if the comet had been rewritten by the sun itself. Back on Earth, observatories scrambled to interpret what had happened during those missing hours. Some believed 3I Atlas had experienced a super-volatile outburst, an explosion of trapped gases deep beneath its crust. Triggered as sunlight heated its ancient ices, the pressure would have fractured the surface, sending geysers of vapor into space, doubling its brightness. Others suggested fragmentation, that the nucleus, perhaps no larger than a mountain, had cracked apart under tidal stress, exposing layers untouched for billions of years. But the brightness pattern didn't fit. Instead of fading quickly, the glow persisted for days, as if some internal engine were feeding it from within. Then came the strange part, spectroscopy. Teams at the Subaru telescope in Hawaii noticed that the comet's coma emitted light in non-thermal wavelengths, frequencies that don't come from heat or reflection. This hinted that 3I Atlas might have undergone electrical excitation, possibly interacting with the sun's magnetic field in a way no natural comet had before. What could cause an interstellar object to behave like that? No one had a definitive answer, but whispers began to circulate across scientific circles, quiet speculations that made even the most seasoned astrophysicists uneasy. One of them, a researcher at the Max Planck Institute, wrote in a private paper draft, "We are witnessing a form of plasma resonance we don't yet understand. It's as if the object is responding to the sun." The message hypothesis to the public. 3 Atlas remained a beautiful mystery. A cosmic visitor briefly catching the sun's fire before disappearing forever. But within the data, something else lingered. A faint modulation appeared in the spectral line intensity. Rhythmic, structured, recurring every 6.3 minutes. It wasn't radio noise. It wasn't solar interference. To some, it looked like a pulse. Most dismissed it as coincidence. Others proposed that the pattern could emerge from rotational dynamics, the spin of the comet exposing active vents at regular intervals. But among a smaller, more speculative group of researchers, including Harvard's Avi Loeb and members of the Galileo Project, another idea formed, that the modulation might represent an encoded natural pattern, perhaps a byproduct of material engineered or modified before its interstellar ejection. It sounded impossible until the math suggested it wasn't. Simulations showed that if 3I Atlas's surface included a metallic lattice, perhaps from cosmic ray sintering or exposure to unknown stellar radiation, it could generate quasi-coherent plasma discharges under solar interaction. To the untrained eye, it would look like light flickering. To a radio spectrometer, it might look like a message. The cosmic mirror still, the mainstream view remains simpler, that 3I Atlas is a relic, not a messenger. a wanderer from another stellar nursery, carrying within it the chemistry of creation. Even so, the implications are staggering. If its isotopic ratios confirm it was born around a different star, perhaps a red dwarf 10 billion years ago, then 3I Atlas isn't just older than Earth, it's older than our Sun. A fossil from the galaxy's youth, drifting through darkness until gravity drew it near. And yet, there's poetry in that. This frozen traveler, once lost between suns, now burns briefly in our sky, like a story half-remembered by the universe itself. For centuries, humans looked up and saw comets as omens, harbingers of change, messengers of destiny. But today, we see them for what they truly are: time capsules. They carry the raw ingredients of stars, planets, and perhaps even life. When we analyze the dust tails of comets like 3I Atlas, we find amino acids, glycine, serine, molecules that form the basis of biology. It's possible that comets like this seeded Earth itself billions of years ago. If so, then every living thing, every thought, every heartbeat may trace its origin to these wandering emissaries of ice and dust. Atlas, then, becomes more than a discovery. It becomes a mirror, showing us not who we are, but where we came from. Beyond the horizon by February 2026, the comet will fade into the deep sky, its path curving outward past Jupiter and into the cold void beyond Neptune. Its trajectory ensures we'll never see it again. But in that fleeting encounter, it has already transformed science. The James Webb Space Telescope continues to analyze residual light curves from its outburst, while the Punch mission compares magnetic field signatures from that strange flare near the Sun. No definitive conclusion has been reached, but one thing is certain. Atlas broke expectations. Every model of cometary physics has had to adapt. Every assumption about the composition of interstellar bodies has been challenged. Perhaps, in the end, it didn't break the laws of physics. It merely reminded us that we don't yet know them all. Epilogue. The quiet return as it drifts away. The emerald glow fades to gray. The sun's light no longer ignites its core. The data signals slow. The cameras turn elsewhere. But somewhere, beyond Saturn's orbit, that ancient traveler continues, carrying dust forged in another sky, atoms that once belonged to a forgotten world. And maybe, billions of years from now, it will cross into another solar system, another civilization's sky, and spark the same awe, the same questions. Who sent this? Where did it come from? And what story does it carry within its light? For now, all we can do is watch and listen. Because every once in a while, the universe speaks, not in words, but in comets. And 3I Atlas, drifting back into the dark, may be the loudest whisper we've ever heard.